I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Monday, September 7th. Tonight we'll be discussing jet stream roller winds, surface level pressure, significant wave heights, and all the things that go into making surf in the North Pacific Ocean. Let's get to work. Looking at significant wave heights for the South Pacific Ocean, we see a gale generating a small area of 33 or 34 foot seas under New Zealand, but that isn't expected to last very long, and not much, if any, swell is expected to result from it. Otherwise, remnants of a gale over in the far southeast Pacific are targeting Chile, but doing nothing for our forecast area. Let's move on. As usual, we'll start looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales when they do form, help direct their track. We're looking for a trough, that is a push in the jet to the north, exactly like we have there. But we also want to see it falling to the south, and what that helps do is set up a clockwise flow aloft, and that's the hallmark of low pressure in the southern hemisphere. And also it sets up the same sort of circulation down at the surface. And if it's deep enough, it generates winds. If the winds are strong enough, so that generates seas. If the seas are large enough, that generates swell, and swell, when it hits your beach, starts producing surf. All right, so we have something that sort of looks like a trough, but behind it, the jet is pushing hard to the southeast. This is a ridge. Notice the split in the jet stream here. That typically produces high pressure and does nothing for generating surf. So we have a little window of opportunity right there. And east of this area, we basically have no southern branch of the jet stream at all, and it's the southern branch that is the most influential in terms of supporting gale development. So as we move into Tuesday, that trough completely vaporizes. Instead, we get this sort of call it a zonal flow, where the winds just blow from west to east. No troughs involved. And that sort of continues as we get into Wednesday. Then another ridge starts building on Thursday under New Zealand. A little bit of a trough right in here is forecast is late Thursday into Friday. And then, but that really doesn't push south either. Probably not offering a whole lot. Not a lot of wind energy in this. And then another batch of wind energy pushes under New Zealand on Friday. I don't know if it really qualifies as a trough or not, but theoretically it maybe could help gale development slightly. But that too pretty much falls apart as we get into Sunday. And then Monday, things looking pretty weak. And then Tuesday, maybe another trough trying to organize under New Zealand. But the pattern, just get the sense there's no real well-defined troughs, not real good support for gale development. All right, let's go take a look down at the surface, see if anything else piques our interest. So here we go. As of right now, weak low pressure in the far southeast Pacific, generating 35-knot winds, aimed at Chile and Peru, doing nothing for us. Another gale south of Tasmania, southeast of Tasmania, is generating wind, but most of that wind looks to be aimed southeast, not aimed in our general direction. And there is that fetch that we saw that was generating 32-foot seas. It's right on the edge of the ice line. The ice line's about 61 south right here, pretty far to the north. And this gale quickly just disintegrates. Now notice there's another gale over here in the far southeast Pacific in fact, let's go back, starts tonight and pushes almost out of the Southern California swell window as we get into Tuesday morning, then gone. Not sure if anything will come from that. Then we have a broad fetch at 25, 30-knot winds here, but you need a lot more wind energy than that. It even gets to 30 to almost 35 knots, but really you need 35 to 40-knot winds over a good-sized area to generate enough period to make it up into California and Hawaii. So we get into Thursday night, another gale gets going in the far southeast Pacific, but is out of the swell window. And then this system here, forecast on Friday, it was Thursday night, it had 55-knot winds. pretty well organized in the California swell window, believe it or not, pushing under New Zealand on Friday with 45-knot winds over a broad area aimed off to the east, and then continuing at 35 to 40 knots as we get into Saturday, and then fading out. That looks like it has some potential indeed. Then things sort of back off, but notice this broad gale trying to get organized as we get into Monday. Let's see if that does anything, and no, you can see just 30-knot winds. Oops, and we were at 180 hours out. So that's kind of it. One system, it looks like, for the next week. Let's go take a look at the effect of those winds on the ocean surface. But before we do that, we're going back almost a week. We're going to Sunday night, not yesterday, but the week before. And even before that, like Saturday, there was a solid gale pushed under New Zealand with 42-foot seas. By Sunday night, it was fading with 31-foot seas and then fading out. Swell from this system is just now starting to arrive in California. It hit Hawaii maybe 2 days ago. And there was some shoulder, maybe head-high peaks, something like that. Nice little run of surf. And that swell, as I said, is starting to arrive in California and should peak on Tuesday. Another system developed right behind that, a tiny little system pretty far to the south, running flat east to west with 42-foot seas, a good sea height, but over a very small area and not aimed well to the northeast at all. Maybe some sideband swell from that. And then yet another system last Wednesday produced, let's go back a little, right there, 27-foot seas pushing under New Zealand, trying to lift northeast, but at least it got a little bit pushed to the northeast. Tiny swells expected from that. I mean, 27-foot seas, you get 15-second period. It decays pretty good over the 6,500 nautical mile journey up into California, but Hawaii and California should see some barely rideable surf out of that. And then where are we? We're at Saturday, just a couple days, 2 days ago, and then Sunday, and I think that is it. Right. Right, so now moving forward, we have a little gale down here south of New Zealand as we get into Monday night. Tiny area, 32-foot seas, but doesn't move to the northeast. It dies. No swell expected from that. We're completely writing that one off. Though the reality is maybe some small background swell because it even has, look at this, it has like 26, 28-foot seas, mainly, again, oriented west to east, not pushing off to the northeast, but maybe some little background swell to result. Then we get into Friday, things get more interesting. Stronger gale building under New Zealand with 47-foot seas. Well, let's go back to Friday morning. That's actually in the California swell window, but a long ways away. 48-foot seas, 47-foot seas, 47-foot seas, fading to 45 as we get into Friday night. And then Saturday morning it was 40 feet, then fading from there, but should get a decent run of surf from that if it materializes. Again, the concern, the jet stream doesn't show really any support for this, so it's kind of unsure where it's to get its energy from. And then a building area behind that in the Tasman Sea, certainly good for Fiji, but not so sure about greater, and that was 180 hours. For the greater Pacific, like Hawaii, a little background swell for Hawaii. It gets pretty well shredded after it passes through Fiji and the islands here before it gets to Hawaii, and odds are probably nothing for California. So one more in the future beyond the three that are already queued up, those small. Next up, looking for wind swell production potential. So today in the San Francisco Bay Area, there was maybe some peaks that were waist high. Not good support for wind swell production. Nothing really along the east shore of the Hawaiian Islands, thigh high, waist high. So we get into Monday night, winds pick up. Only 15 knots out of the northeast. Get into Tuesday, that pretty much vaporizes. There's stronger fetch building off of Oregon, but it's all aimed to the northeast. No wind swell from that. Nothing for Hawaii still. Get into Wednesday, and then the wind machine just completely dies off. Same thing Thursday. Same thing Friday. Just no support for wind swell production. Saturday, no real change. A little bit of wind, 15 knots. Along central California. No wind swell from that. So even next weekend, nothing really expected. And then we're getting into Monday. We're almost a week out. And again, A little bit of fetch here along. I mean, I guess down at Point Conception there'll be some wind swell, but that would be about it. Finally, maybe some fetch starting to arrive. Easterly fetch along east shores of the Hawaiian Islands on a week from now. I don't believe the model's that far out, but maybe there's some hope. A quick look at precipitation potential for California, specifically the Sierra, for anyone out backpacking or hiking. The expectation is bulletproof, high pressure and control. We're looking for any sign of precipitation, and it just looks like high pressure, at least in the upper levels, has just locked everything down. No rain. Oops, and we're the whole way through the week, nothing. We've been playing around a little bit, working on a different style chart. Again, this is like a spot location. In this case, it's Mount Whitney. And what we're trying to do is show temperatures at different levels of the atmosphere, especially if you're backpacking, hiking, or even skiing for that matter. So Whitney goes up to about 14,000 feet, a little bit more than that. We have data up to 14,000 feet. The base of Whitney over there on the east side of the Sierra is down around 3,700 feet. So the idea being is, as you go up in elevation here on this side, it shows you what the temperature profile will be, and it's this is 10 days in a row, whichever model run you get. In this case, it was the 06Z run, so it starts about 11 p.m. on Thursday, and this was old data. This is just a test data set. But you see heating during the day, cooling at night, and you see the wave function here. The red line is the freezing level, so if you're hiking at Whitney, and you're at 7,500 feet, you can see it starts out in the 20s, and as you get into your trip, if it's multi-day trip, temperatures get in the 40s, 50s, they get cold, that sort of thing. So it's a profile at elevation, depending on your elevation you're at. We'll be working on this, and it's probably a variant of it that shows just the freeze level for if you're skiing. So between the two of those charts, this can give you a good idea of whether you're going to have precip or whether you're going to have snow, how cold it's going to be in the day and the night, and it's not fixed at one height. It's, the temperature at the base of the resort and at the top and anywhere in between. All right, so that's something. All right, let's go take a look at long term. What's going on with the Madden-Julian Oscillation? And of course, El Nino or La Nina. So as usual, we're very interested in winds on the equator, specifically in the West Pacific, and that gives us clues as to what the MJO, the Madden-Julian Oscillation, is doing. And why do we care so much about the Madden-Julian Oscillation? Because when in the active phase, it helps impart energy into the jet stream, and that in turn helps feed storm production, which of course helps produce surf. All right, and also if you have successive active phases in a row and they're strong enough, they can help create things called Kelvin waves. It's basically warm water in the West Pacific starts moving to the east, and that can be a harbinger of El Nino. All right, so today, here's the East Pacific, here's the West Pacific, here's the equator. This is the date line right here. We're just looking at the arrows. The arrow, and this is 5-day average winds from the TAO buoy array, series of buoys strung across the equator. You see the arrows strong out of the east, strong east trades over the East Pacific, Central Pacific, and then in what we call the Kelvin wave generation area, this area far West Pacific from 135 east to 170 west, 5 degrees north and south of the equator. Draw a box in your mind right there. That is the key area for energy transport to the jet and for Kelvin wave generations. Anyway, winds here out of the east, pretty strong, but it's not the actual winds, it's the anomalies, difference from normal for this time of year. We see in the East Pacific, the winds are pretty strong, stronger than normal out of the east. And you see the sea surface temperatures here below normal, 2.5 degrees centigrade below normal. Over the Central Pacific, a little bit stronger out of the east than normal. Over the Kelvin wave generation area, a little bit stronger out of the east than normal. So this is probably a suggestion that we're in the inactive phase of the MJO. Okay, the MJO is like a low pressure system, and it moves west-east across the Pacific, takes about 3 or 4 weeks. But when it's doing its thing, it either dampens or can completely reverse trade winds such that they actually start blowing out of the west. That's what we want to see. The forecast for the next 7 days is from the GFS model. Whole planet on one chart. The date line runs right up the middle. The Pacific starts about 135 east, so right there. and goes over to about 80 west. But it's the Kelvin wave generation area that we're really interested in. From there to about there, going the whole way up the chart. So like that. The blues are easterly anomalies, and you can see right here, easterly anomalies have been in control of the Kelvin wave generation area since late August, and so far all of September, working their way the whole way over to Ecuador. The next week, forecast to be in control. No sign of the active phase of the MJO, inactive phase, so this means decreased support for gale production. Looking a little bit further out, we go to these models. They go out 2 weeks. This is outgoing long wave radiation, another component of the MJO. When you have, so the active phase of the MJO is like low pressure system. It has a lot of clouds associated with it. You get less sunlight reflectivity off the ocean surface. You get what they call negative anomalies. Okay, and that would be blue shading. But you look at this chart, there's South America, Central America, where we go, New Guinea there, Australia, you get it, the equator right down the middle. So in the West Pacific, in the Kelvin wave generation area, pretty much a neutral pattern in terms of cloud cover. Not increased cloud cover, not decreased. No sign of the MJO now, 5 days from now, 10 days from now, 15 days from now. Nothing, no change according to the statistic model. And the dynamic model suggests pretty much the same thing. Virtually no change. The models are in sync. Phase diagram charts, another way of looking at the MJO. See that circle there? Assume you're looking down on the North Pole and the planet rotates underneath that. Okay, where the MJO moves from west to east, from the Indian Ocean over the Maritime Continent, over the West Pacific, East Pacific, under the United States, across the Gulf of Mexico, across the Atlantic, over North Africa, back to the Indian Ocean. Where the heavy dot is where the active phase is. So somewhere between the Indian Ocean and Bali sort of thing. And if the dot is inside the circle, or the closer to the circle it is, the weaker it is. So very weak. And this is the track. So forecast very weak active phase moving into the West Pacific, into the Central Pacific over the next 2 weeks. That's for the statistic model. The dynamic model says pretty much the same thing. Maybe the active phase a little bit stronger in the far West Pacific 2 weeks from now. Going out a little further, this is 40-day. This is the 40-day upper level model. Okay, a bunch of panels here, but you see South America there, Central America, the equator right there, New Guinea right there, Kelvin wave generation area in this area. Where the yellows and oranges are areas not favorable for precipitation. So one could equate that to the inactive phase of the MJO. And you can see inactive phase now through and moving into Central America while fading out about through September 22nd, 27th, something like that. And a very weak active phase, favorable for precipitation, but exceedingly weak, not even really coherent, trying to make its way across the Pacific into about mid-October, and then another inactive phase behind that. So the models had been showing a very coherent, strong MJO pattern, and now as of the past 5 days, that strength has just vaporized from the models. And that's not good. I mean, that sort of gets us back into this pattern we were last winter where the MJO was just weak. You got to have momentum. You got to have energy to get storms. And the MJO is a good early signal of what's going to happen weeks in advance. And we're not seeing anything too dramatic here at all. So then finally we go look at the 3-month CFS model. Long look into the future. So same deal, whole planet one chart. Date line runs right up the middle. Kelvin wave generation area from about here to about here. And this is past performance here. The forecast is the future. We're eyeballing it. Blues are easterly anomalies. We see a long run of easterly anomalies in the Kelvin wave generation area into about middle of October, and then they become a little bit more isolated in the East Pacific, with westerly anomalies taking over. Let's overlay the MJO. Here we go. So today, inactive phase, the dotted contour, inactive phase of the MJO, and it makes its way across and out of the Kelvin wave generation area, about October 12th or so, and then an active phase shows up. Now, the good news is westerly anomalies were not forecast to take over the Kelvin wave generation area, but with this run of the model, looks like very weak, but they're there. That might give us a window of opportunity to support storm development. We'll say, mid-October into about mid-November, something like that. And then the inactive phase comes in after that till about through December 5th, the end of the model run, but still westerly anomalies trying to take over. This is actually an improvement because this had shown easterly anomalies very strong over the whole Pacific for months. Now it's looking a little bit more normal. Let's overlay the low-pass filter here. Here we go. All right, so this dotted contour is a high-pressure bias. Expect one contour line building to two contour lines in a couple of days, maybe the 10th or 12th or something like that, and forecast holding with the low-pressure bias over in the Indian Ocean. That's where all the storm activity is. Wherever the low-pressure bias is where you want to be, and this is the typical La Nina sort of setup. High pressure takes over the Pacific Basin. The high-pressure bias is control. High pressure creates stronger than normal trades. Trades create upwelling. They then stomp on precipitation. They make it much more difficult for storms to organize, and so you end up with drier conditions over California, no rain, no snow, and smaller or weaker or shorter-lived lasting swells. The good news here is as we get into December, the high-pressure bias is to almost be out of the Kelvin wave generation area, and the low-pressure bias is to start easing about midway into it. So there's some hope there. Maybe not for this winter, but as we get into spring, maybe the high-pressure bias will get knocked out, and that'll be the end of our La Nina pattern. But that's only a guess at this point in time, and we're looking 3 months out. We don't even trust a model more than a couple of days in advance, much less 3 months out. So we'll see. But this model has been fairly reliable so far. All right, so enough of the MJO. Let's go talk more about El Nino, La Nina. First off, let's see what the ocean, not the surface, but down in the ocean, what the ocean thinks is going on. So this is West Pacific here, East Pacific here. The X's are the sensors on the TAO buoys array. This is TAO buoy array data. The sensors provide us data, couple that with a model, and you get a profile of what's going on across the entirety of the Pacific on the equator. And the short picture is, you can see it plain as day. Warm water is balled up in the West Pacific and much less of it in the East Pacific. No big surprise, since we know that trades have been blowing strong on the surface for months now. So that's typically what happens. That's a sign of La Nina. And then we look at anomalies, the differences from normal for this time of year, and no big surprise again. Cooler than normal water, -2 degrees centigrade, so what's that about? 3.5 degrees below normal, filling the entire Eastern Pacific from, where is that? That's about 170 is there, so we're just coming, from about 170 almost to the date line, from the date line the whole way into Ecuador. Cooler than normal water, of course driven by the stronger trades. Any warm water, any hint of a Kelvin wave or anything like that, driven by the active phase of the MJO. Well, we're not seeing any active phases, so it's no surprise that the warmer than normal water is very weak in the far West Pacific and making no signs of moving to the east. Here's a little bit higher res model using the same raw data. It's telling us the same picture, maybe even worse. 1, 2, 3, 4, 5. We'll say 5. 1, 2, 3, 4, 5. 3 to 4 degree temperatures below normal, filling a good portion, if not all, of the East Pacific, and again, all the warm water balled up in the west. So what happens is eventually you'll get so much warm water balled up in the east, and it actually raises the ocean surface over here, that this water will slosh east, maybe after a year, maybe after 2 years. This is what we call the recharge cycle. The beginning, you have to have energy. You have to have heat building up in the Pacific if you want El Nino. This would be the recharge period before the start of El Nino. We're in La Nina, so at least a year, maybe more out. Sea surface height anomalies, not temperature, height. So this is South America here, Central America there, the equator here, date line there, Kelvin wave generation over here. Those of you that have seen this before, so we see negative anomalies. The ocean surface is 10 centimeters below normal over the entire eastern Pacific. Why is that? Well, colder water at depth contracts and it creates the divot on the ocean surface. That's what we're seeing here. Oh, the positive anomalies, we'll say 5 to 10 centimeter anomalies, only within 5, we're only looking 5 degrees north and south of the equator. That's all here. Warmer than normal water expands, creates a bump on the ocean surface. And so this is basically confirming what we saw in the previous charts. And then this is the trend for the past year. Okay, West Pacific here, East Pacific here. Oranges and yellows are warmer than normal temps. Blues and greens are blues colder than normal temps. So last year in the fall, Kelvin wave, 1 Kelvin wave traversing the Pacific, pushing into Ecuador here. Another Kelvin wave, sort of a double. First one didn't quite make it. Second one, driven by the active phase of the MJO, did make it almost to Ecuador, and it died. And then in May, we started with a cool bubble. We had one of these last year about the same time frame too, but only one of them died. But now we have a second one building as we get into August, also equally as strong, and it wouldn't be surprising if we get yet a third one before this is all over. So basically like a cold water Kelvin wave, but not really, because they don't traverse the Pacific. They're more a result of upwelling driven by strong easterly trades over this part of the Pacific. And then another component of the El Nino-La Nina cycle, sea surface temperatures, and a clear pattern is here. So the yellows and oranges are warmer than normal. Blues are colder than normal. We see pockets of purple here off of Ecuador, the whole way out to almost the date line, but this area here building intensely the past week or so. Strong easterly trades on the equator in control, meaning that high pressure, both in the northern hemisphere and the southern hemisphere, are in control, driving the trades. And so this is a classic La Nina signal. Sea surface temperature trend for the past 7 days, and only on the equator that we're interested in, 5 degrees north and south. The blues is cooling temperatures, no surprise, darkly, strongly cooling from Ecuador to a point south of California, and then continuing almost out, I'll say out to Hawaii. So if it was cold in what we're seeing now, it's only going to get colder as the trades continue to nuke. We see no active phase of the MJO. If anything, a long inactive phase, lots of easterly anomalies. This is no surprise, a building La Nina pattern. And then finally, the overview. Sea surface temperatures anomalies, differences from normal for this time of year. Again, clearly that blue pattern taking over the equator, a clear sign of La Nina. Though we see reds all up here, it's what's on the equator that matters, and especially, like for precipitation for California, south of California, right in here. This is the Nino 1.2 region here. The official El Nino monitoring region is from 120 west out to 170 west, 5 degrees north and south of the equator. Definitely cooler than normal temperatures there, but strongly cooling off of Ecuador, suggesting a dry winter ahead. The sea surface temperature anomalies by zone. Nino 1.2, this is right up by Ecuador. Temperatures you can see since mid-May, dropping steadily there. Nino 3, a little bit further out, but not the full El Nino region. Again, the same pattern, cooling temperatures to down to 1 degree below normal. The official El Nino monitoring region, according to this, 3/4 of a degree below normal. And then out Nino 4, that's out even west of there, out towards the dateline, starting to cool. And here's a different view. This is a daily updated view. The Nino 1.2 region, right there about along the Galapagos, Ecuador, Peru. Temperatures 1.891 centigrade below normal today, and they've been holding there. They've been steadily, slowly drifting down. They're probably bottomed out. It's pretty hard to get much cooler than that, but that's cold. The official El Nino monitoring region, this is where it really matters. The trend in June and July, we were neutral. We're on a steady downward tear now. Today, 0.670 below normal. We were down a little bit cooler than that, 0.69 maybe 5 days ago. We suspect we're still going to be heading down from here. And then the final component of El Nino, La Nina, Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. If you were in El Nino, you'd have lower than normal pressure in the Pacific. So in Tahiti, your pressure would be lower, and this index would be negative. If you're in La Nina, pressure's higher in the Pacific, the high pressure bias that we talk about, right? And so the index would go positive. Today's value, plus 13.31. This is the daily contribution, just eyeballing down here. 11 days have been positive, and just scanning through, it's been by and large positive and strongly positive for a month now. The 30-day average today, plus 9.74. When this starts getting up at about 15, you start getting worried a little bit, because that means you've had 30 days of pretty solid positive numbers. We were at plus 4.47, been heading upwards since there. The 90-day average, this is a lagging indicator, lagging by 3 months, but today we're positive there, 3.69, and it went from neutral to moving positive, suggesting the arrival of La Nina. But this has to get up to like plus 12, something like that, before you're official in La Nina. But by the time it does that, again, this is like a 2-month lag, 3-month lag. So it's probably almost over with by the time you get to the peak. Here's a 30-day moving SOI on a graph. It tells you the same story. Last year, we were falling negative, moving into barely El Nino territory. We weren't, but from a pressure perspective, we had negative anomalies, a low pressure bias in the Pacific, and then that was in 2019. And then as we got into January, see the upward trend. These are the downward spikes are the active phase of the MJO. The upward spikes are the inactive phase. You can see from July onward, we really haven't had an active phase. It's all been inactive phases pushing upward. So again, more data suggesting the arrival of La Nina. Here's a sea surface temperature forecast for the Nino 3.4 region, the official El Nino monitoring region. Where are we now? We're in September, down in here somewhere. Temperatures, according to this model, we should be, well, let's see, September 7th, so we'll say right around here, about 1 degree below normal. We're really at, what, 0.65, something like that. So this is a little bit overstated. Either way, this model says we're going down to minus 1.6 degrees below normal as we get into late October, January. That's pretty cold, probably a bit overstated. And then theoretically, returning to neutral after we get through spring, probably be a pretty tough winter in spring in terms of wind, upwelling, coldness, and not so much surf. And then here's the actual sea surface temperatures like on a chart. And if you can see this, I'm trying to look around the camera while I do this. Cold water off of Peru, cold water, we'll blow up. Let's blow up January, see what we get. There we go. And there's South America. See the cold water plume right there? That's classic La Nina sign going the whole way out to the date line. There's California there. Yeah, we see warm water all around it, but this is what drives the global atmospheric circulation, the jet stream. You'll see when you get this, the jet stream starts going further. So it builds high pressure right north and south of it, starts driving the jet stream further up to the north. It's hard to get storms into the Gulf of Alaska, hard to get snow and rain into California. Whatever activity you have in the Pacific, it's over in the West Pacific where most of the energy really becomes focused on the Indian Ocean and the Atlantic. So to wrap things up real quick, right now we have small southern hemiswell coming in California. Make the most of it. It's only a day or two's worth. Then theoretically 2 or small, just micro swells right behind that going through the week. Probably best down in Southern California, not so much for Northern California. The good news is the models are showing a decent southern hemiswell on the charts for under New Zealand, about not even quite a week out, maybe 5 days out. So maybe some more coming. Looking in the North Pacific, we didn't actually even go look at the charts, but there's literally no organized systems in the North Pacific. The earliest we've ever seen is October 15th for some sort of a swell coming from the North Pacific. August 15th, I say that. Anyway, we're not seeing anything, and we're September 7th now. So, but this is not a surprise when you're into La Nina. That's typically what kind of happens. Delayed start to winter, and then when it even does start, it's weak and not doing a whole lot. Further, as we get into winter, looks like La Nina, pretty much a sure thing at this bet. There's no way you're going to change the pattern that's setting up now. If anything, it's only going to get more entrenched. So the plus side of that is let's do it. Let's get this over with, and let's get La Nina out of the way so that at least we can get back to a normal pattern or hopefully a warmer pattern a year or so out from now. All right, so that's pretty much it for this week. If you enjoyed the video, give us a thumbs up. We'd appreciate it. If you haven't subscribed, please subscribe. You'll get an email notification. If not, you can go to stormsurf.com. All the data is there on the site. You can follow along daily and then check with us on the video. Normally on Sundays, we had a little technical difficulties last night, so we're retrying it again today. And that's it. So thank you for watching, and we'll do this again next week, same time, same channel.